nice thing is, starting with this chapter, we're going to actually have note sheets for you all to follow along with, unlike Chapter P. Now with this here, Chapter 1, there's first thing is we're going to have is some vocab terms, and we have these here. First one is an angle. An angle is two rays with a common endpoint. That's just the definition of an angle. A vertex is the endpoint of the two rays. The initial side is the starting side of the angle, and the terminal side is the ending side. And it's really, initial terminal is wherever the angle is considered to start and go to. And we call that amount of the turn from the initial to terminal side the angle itself, what its measure is. Okay. Questions over any of these definitions so far? Positive angles, negative angles, and coterminal angles. A positive angle is going to be going counterclockwise. Is what we're going to consider positive angles. And this is mainly in reference to a Cartesian plane, a coordinate plane. Because if we're looking at the XY coordinate plane, we're talking about angles. We're talking about going in a counterclockwise direction. Negative angles are going to be clockwise. Our initial side, especially on the coordinate plane, is going to be the positive x-axis. That's going to be the initial side every single time. That's where it's going to start. And then our terminal side is going to be wherever our point or location is on the graph. And when we talk about a positive angle, we're going from the initial side to the terminal side. If we're going counterclockwise, it can also be down here in this direction, as I just drew, would be clockwise, so it would be considered a negative angle. Now with any of these here, we can have a positive and negative angle. Because going from the initial side to the terminal side, as is pictured, would be a positive angle. And we could say that this is 120 degrees. But we can have a coterminal angle, an angle that is same but going in the opposite direction. Because going this way would be negative 240 degrees. So negative 240 and 120 would be considered coterminal angles. They're going to the same point, but one's positive and one is negative. Any questions on any of this so far? And we can have many different coterminal angles that get us to the same spot, because they don't always have to be positive, negative. We could have multiple positive angles as well. Yep, such angles, so they go to the same spot, are considered coterminal. Now, as I just showed, we could have positive and negative to get there. Now, what is the measure of a circle? Full circle is 360 degrees. So going here, we said is 120. Here's 360. 480 degrees would also be considered a coterminal angle. We can go all the way around and get back to it. So the number of coterminal angles that we can have is almost infinite, because we can keep going around and getting to it. Questions on positive, negative, and coterminal? Now you determine the measure of angle by the amount of rotation from the initial side to the terminal side. One way to measure an angle is in radians. This type of measure is especially useful in calculus. is defined. To define radian, you can use a central angle of a circle, one whose vertex is the center of the circle as shown. And S, the side of here is equal to R because these are the same. And we can use that to go about finding the radian measure. So our radian measure, theta, is equal to S over R. So R is our radius. Well, R is our radius. And S is the amount along the circle that we've gone. Now S, if we go all the way around, is 2 pi R. Yeah. Now degrees, if we talk about this in degrees, the whole circle is 360. Now with radians, because we have this here, 1/2 of a revolution is 2 pi over 2, because we did half the circle, or pi. So this is half of a revolution here. If we did 1/4, so we're looking at this top one here, we're looking at back that up, not that one. This one over here. 1/4 of a circle, 2 pi over 4, or pi over 2, looking at 90 degrees. Or 1/6, 2 pi over 6, pi over 3. 1/6, 1/4. And these here are our different circles that we can have, different parts of how far we've gone over the whole circle divided by how far we've gone. Because we could go 2/3, we could go 1/8, we can go any amount and kind of relate it to 2 pi. And we have the same thing with degrees. Because we could say pi over 6, we've gone 1/12 of the entire circle would be pi over 6 or 30 degrees. Well, 1/8, 1/6, 1/4, 1/2, and then the one whole circle. And we do get these here. Now we could do multiples of them because we can continue going around and around the circle and getting different values, increasing amounts. We have coterminal angles for these here. Questions on any of this so far? We know that the 4 quadrants in a coordinate system are numbered 1, 2, 3, 4. We've talked about this before. You've talked about this in Algebra 1 and Algebra 2. The figure below shows which angles between 0 and 2 pi lie in each of the 4 quadrants. Note that an angle between 0 and pi over 2 are acute angles, and angles between pi over 2 and pi are obtuse. Because we do have this here, 0 and pi over 2, or 0 and 90 degrees. And if we go all the way around between pi over 2 and pi, or 90 and 180, we would indeed have an obtuse angle. And then I'll go on and fill this in because this is going to be 270 and over here is 360. Now, if we want to find the coterminal angles, we're just wanting to get back to it. Find different angles that work together to get to the same thing. Because on the quadrant plane, we can look at that there, or we can look at it in terms of this here. Now, if we were to graph this, 13 pi over 6 is going to be in one of the 4 quadrants. And it's figuring out where that's at. And it's going to work out to be in the first quadrant. Now, part of the way that we deduce this and work this out is really looking at the number as a whole. Now, all radians, or not all, most radians are going to have pi. They're going to be in terms of pi. That's how we're going to look at these for the most part. The only time they really won't have pi is if we're getting our answer in radians, and it gives us a decimal answer. It has pi built into it or calculated into it. So I'm really not looking at the pi. I'm looking at more of the 13 over 6. Now for us, in terms of radians, we have 0, pi over 2, pi, 3 pi over 2, and then comes all the way around to 2 pi. Now, if we look at 13 over 6, is 13 over 6 greater than 2? 13 over 6 is greater than 2, because 2 in sixes would be 12 over 6. So it is greater than 2 here, which means for this angle, we have for sure come all the way around. Yes? Now, how much greater is this than 2? Because we have what? 13 over 6, yes? So how much greater is it? 1/6. Which means this angle right here is 1 over 6 pi. 1 over 6 pi units, or pi over 6. Questions on any of this so far? So, what we can say for certain is that a coterminal angle for this is pi over 6. And we can go about finding different angles from this here. But, and this is graphically, so we understand kind of how this looks graphically. Now, another way we can find coterminal angles algebraically is taking 13 pi over 6 and adding 2 pi to it. So, in these here, I would use the 30xs. It's a little bit nicer in terms of pi and plugging fractions in. Because I can plug 13 pi over 6 and add 2 pi to it and get 25 pi over 6. So 25 pi over 6 is a coterminal angle. Now we can also, instead of adding it, we can do what? Subtract it, and let's see what we get. Which is what we got graphically. Essentially, we did the same thing. Now, we don't have to do it once. I could subtract it again. Minus 2 pi and get and our negative 11 pi over 6, let's do a different color, is really just this angle here, if we went one time around. Now, if we did it again, we could subtract 2 pi again and find another coterminal angle. Does this make sense? And really with finding coterminal angles in radians is more or less adding or subtracting 2 pi. And that's it. Questions on this here? So if we looked at the next one, negative 2 pi over 3, well, to find a coterminal angle, we can add 2 pi to it. In the calculator, we can say negative 2 pi over 3 plus 2 pi, which is 4 pi over 3. And we could add it again. We could say 4 pi over 3 plus 2 pi, and get 10 pi over 3. And we could keep doing that. Now we could also, instead of adding it, we can subtract it. And get negative 8 pi over 3. And here we found 2 positive and 1 negative coterminal angles. And if we wanted to find another negative coterminal angle, we can subtract 2 pi from negative 8 pi over 3. And that's it. Questions on these coterminal angles? Now we can also do it with degrees. But with degrees, we're not going to add and subtract 2 pi. We would add and subtract what? Because what's a full circle? 360, because a full circle in radians is 2 pi. So for 135, I could add 360 degrees, which gives us 495 degrees. And again, we can add 360 to it, which gives us 855 degrees. And we could also find negative angles by subtracting 5, 2, which would be negative 125 degrees. And we don't have to do these by hand. We could do these in a calculator. No, almost, not 1. That should be a 2. 135 minus 360 is negative 225. Unnecessarily carried a 1. Now, most likely, I believe on the homework, if I remember correctly, it's going to ask for 2 positive and 1 negative angle. So we have to do this here. We add it twice and subtract it once. And we can do the same thing with 540. I can add 360 to it. $900. And we can do it again. We can say 900 plus 360, 0, 6. 1260. So we found 2 positive angles, yes? Now we can also subtract 360. 0, 8, which is 180. Well, 180 is still a positive angle. We need a negative angle. So what do we need to do? We need to subtract it more. We need to subtract it again. So our first negative angle we get is negative 180. So if we start out with a really big positive angle, well, we might have to subtract it a few times before we hit our first negative angle. Or the opposite is true. We could start out with a really big negative angle and we have to add it multiple times to get there. Questions on this here? Complementary and supplementary angles. Because coterminal angles is something new you haven't done before. Complementary and supplementary angles is not new. Because we've covered these in geometry. Complementary angles add together to be 90 degrees. Supplementary angles add up to be 180. In terms of radians, complementary angles add up to be pi over 2. Supplementary angles add up to be pi. So what we're saying for complementary angles, in terms of radians, two angles are considered complementary if they add together to be pi over 2. So we can say alpha plus beta is equal to pi over 2. Or supplementary, our alpha plus beta is equal to pi. But if we're given one or the other, we can just subtract it from pi over 2 and pi to find the complementary and supplementary angles. So with 2 pi over 5, if I want to find the complementary angles, add together to be pi over 2, well, I can take pi over 2 and subtract 2 pi over 5 from it to find its complement. So we can say pi over 2 minus, was it 3 pi? 2 pi. 2 pi over 5. Enter. And we get pi over 10. So the complement is pi over 10 radians. Now if we want to find the supplement, and instead of subtracting it from pi over 2, we just subtract it from pi. Which gives us 3 pi over 5. So there's our complement and supplement. Questions on this here? All right. Let's look at the next one, 4 pi over 5. So to find the complement first, we're going to subtract it from pi over 2. So I'm going to say pi over 2 minus 4 pi over 5, which gives us what? Almost negative 3 pi over 10. So does this one have a complement? Well, we do have two angles that add together to be pi over 2, but one of them is negative, which means 4 pi over 5 is actually greater than pi over 2, greater than that 90 degrees. So we don't actually have complements, because complementary angles have to be two positive angles. So there will be some that we look at that actually don't have a complement, but it will have a supplement. So we can do pi minus 4 pi over 5. Which is pi over 5. So there is no complement for B, but there is a supplement, which is pi over 5. Questions on this here? Now the last one, we have 65 degrees, so to find the complement, we're going to do 90 minus 65, which is 25. And we can do 180 minus 65, which would be 115. I think we feel a little more comfortable dealing with degrees than we do with radians. Questions on this here? Questions on anything we've done so far? Degrees to radians, radians to degrees. Now the way we convert from one to the other and vice versa is using a set formula. Now you can write this off to the side. But to go from degrees to radians, you take the degree measure and multiply it by pi over 180. To go from radians to degrees, we multiply the radian measure by 180 over pi. Now this might be something new, it might be something you've seen before. Now this is really revolving around the fact that a full circle in radians is 2 pi. A full circle in degrees is, well, they do have a common factor of 2, which leaves us with pi on top and 180 on bottom. Pi over 180, full circle to full circle. And we're trying to reduce our terms whenever we convert from one to the other, because the numerator is radians and the denominator is degrees. So if we want to go from degrees to radians, we need the degree measure on bottom. If we're going from radians to degrees, we need the radian measure on bottom. So knowing that, when we look at these here, if we want to convert from 135 degrees to radians, well, we're going to take 135 degrees and multiply it by pi over 180. Is 3 pi over 4. Now, if we want to go from radians to degrees, we'll take our radian measure and multiply it by 180 over pi. Which gives us 540. So 540 degrees, if we're converting it to radians, we do pi over 180. And I believe this is 3 pi. It is indeed 3 pi. And last one, 2 radians. So we're going to do 2 times 180 over pi. $114.59. Hold up. Where are we? That's funny. Because this should be pi. No. Yeah. I had that right. No, why? So I can guess 114.59 degrees. Because 2 times 180 over pi, 114.59 degrees. I messed myself up when I put the R, but that is the correct answer. Now, not every radian to degree will always give us a nice number. And the cases when it won't is if pi isn't there. Because here we have 2 radians, we don't have 2 pi radians. A little bit different. Questions on this here? Hopefully also you're noticing that 2 degrees is not the same as 2 radians. It's actually quite a substantial difference between the two. Now, any questions on anything we've done so far? Anything we've covered so far? Okay. Now, probably on a map or GPS locations, you've heard are seeing something like this here. 110 degrees, 52 minutes, 11 seconds, or at least seeing something represented on a map like this here when they gave you GPS locations. What this is talking about is degrees, minutes, seconds, and it's a way to write an angle as a decimal. Another way to write an angle, instead of as a decimal form as 26.5, we can write it in a more precise way. And converting from one to the other is using division. Because there's how many minutes in an hour? 60. And there are also 60 seconds in a minute. So we'll do A and B second. I want to look at C and D first. Because if I want to convert to degrees, minutes, seconds, well, we already have the 26 degrees. And what we're looking at is the 0.5. Because if we want to convert that into minutes, there's actually 60 minutes in a degree. Yeah, in an hour in a degree for this here. So what we'll do is we'll take that decimal and multiply it by 60, which will tell us that we have 26 minutes, and 0.5 times 60 is 30 minutes. And that's it. So 26.5 degrees is 26 degrees and 30 minutes. Now, if we still had a decimal, then we'd move on to seconds. So let's look at D. Now, our 304, our whole number, would be our degrees. Now, our 0.98 is where we would get the minutes from. And just like the previous one, we're going to multiply it by 60. Now, unlike the previous one, multiplying it by 60 is not a nice, easy way to get an answer. But if we do 0.98 times 60, we get 58.8. So we have 304 degrees. And then we have 58.8 minutes. Well, unlike the last one, we still have a decimal. So we're still going to leave the 304 degrees. Here we'll have 58 minutes. But what we're going to do next, we're going to take the 0.8 and multiply it by 60 to get our seconds. 304 degrees. .58 minutes. And then we can do 0.8 times 60 and get 48. So our angle, 304.98 degrees, is the same as 304 degrees, 58 minutes, and 48 seconds. Questions on this here so far? Now, we can do this in the graphing calculator. Second, quit. Clear all that out. So we had 304 point, I want to say 98. Yes, we have this here. Now, if we go second apps, second angle, the fourth one down, DMS, degrees, minutes, seconds. And I could hit enter. And if I hit enter one more time, 304 degrees, 58 minutes, 48 seconds. It'll convert it over for us. So on the previous one, which was our 26.5, 26.5, I can go second apps, degrees, minutes, seconds. And it'll tell us it's 26 degrees, 30 minutes, and 0 seconds. And we get this here. Questions on any of this so far? Now we need to look at this here. Now to go from our angle to degrees, minutes, seconds, we multiplied by 60 and then multiplied by 60 again, yes? So for this here, we're going to have to work backwards or do the opposite. So the first thing we'll do is have to divide our seconds by 60. So we're going to do 11 divided by 60. 0.183 or 11/60ths. Because we can do 0.183, which tells us that we have 110 degrees, 52.183. Well, now we have to divide it by 60. Now, luckily, in the calculator, I can do 52 plus this here, and then divide it by 60. 0.8697. Or if we wanted to simplify, we could say 110.8697. We're not going to normally go more than 4 decimal places. Questions on this here? Does this kind of make sense how this works? Now for the next one, we can do the same thing. We can start off by dividing 19 by 60. So we'll still have the 78 degrees, but now our 10 is going to have a decimal point. 19 divided by 60 is we can say 0.3167. And then we have to divide it by 60. 10.3167 divided by 60 is 0.1719. So we have 78.1719 degrees. Let me get this here. Questions on this here? Now, if you're wondering, yes, we can actually type this in. So 78, if we go second apps, the first one's our degree marker. Because we had 78 degrees. 10 minutes, 10, second apps, 1 down is minutes. 19. Now seconds, we have to go second catalog, second 0. And I would scroll up, and we get this here. Now one thing I'm interested to see, I don't know if it'll let us do this. Nope. Yeah. We'd have to type them in separately. Or do we see how we can type those in? And we could do the same with the other one. 110, 52, 11. 110, 52 minutes, 11 catalog, seconds, 110.8697, exactly what we got, yes? So we have this here. Now we're going to stop at this point.